Hi friends, welcome to my channel. Here we are going to look at problem 3191, minimum operations to make binary array elements equal to 1. So this is the first of such problems. So here we are going to use a sliding window trick. So here we always check windows of size 3, but the moving forward step can be 1, 2, 3. This point will be clear if you follow up. So first I'm going to look at the problem statement, and then we analyze the scenarios, and finally we do the coding together. So here we are given a binary array called nums. So we can do the following operations on the array any number of times. So we choose 3 consecutive elements from the array and flip all of them. So flipping means change 0 to 1 or 1 to 0. So we want to return the minimum number of operations required to make all elements in nums equal to 1. If it's impossible, we're going to return -1. So here are 2 examples. So if you look at the second example, so because the starting is a 0, so we must consider flip this 0 to be 1. So we choose the first 3 elements, and then we make it 1, 0, 0. And then we choose the last 3 elements, 0, 0, 1, and then flip. But once we flip, we're going to get 1, 1, 0. So the last element is always 0 if we make the 3 first elements to be 1. So that's why its output is -1. Well, in the first one, so notice that we have a 0. So we need to flip to make it 1. So we choose the first 3 elements and flip. So we get 1, 0, 0. And then the remaining 3 unchanged. Then we get the leftmost 0. So we have 0, 0, 1, and then we flip them. So we get 1, 1, and 0. And then we have 3, 0. So this way we just need to flip the last 3 zeros to be 1s. So this takes 3 times. So that's the main problem statement. Let's also look at the constraints. So here the length of this list can be as long as 10 to the power 5. So this is basically determines the problem size, while the lower bound 3 basically is a consistency assumption, because we need at least 3 elements. And the second one is also it's consistent with the title, right? So we have a binary list. So because of the problem size, we need to think of time complexity. So because here we are using sliding window, actually you can interpret our solution will be of linear time, or O of m. So here let's look at several scenarios so that we can digest the code and the coding fast. So if you have the beginning element is like 1 something, right? Because the first one is 1, so we don't need to take care of it. So we can slide to the forward. This forward step is 1. So from index I to I plus 1, right? We don't need to increment the count of the number of operations. So for the below scenarios, we need to increment the number of operations. So if you have something like this, 0 and 1, and the others can be anything, then you need to flip this first 3 elements. So you get 1 and then 0 something. So in this case, the forward step is 1, right? Then you need to take care of the second 0 or the first 0 after we do the flip. So the second one, so we have 0, 0, and 1, and the others can be anything. Then if you do the flip, you're going to get 1, 1, 0, right? So in this, you originally at the index I, then you move to index I plus 2. So the forward step is 2, right? Then in other words, you get the move 2 steps to get the first 0 after conversion or flip. So if you have this case, you have 3 consecutive zeros at the left. Then if you do the flip, you get 1, 1, 1. So in this case, originally and here, let's see I, right? So you get I plus 1, I plus 2. Then you check from I plus 3. So the forward step is 3, right? So after we do the sliding window, we can guarantee that the first n-2 element must be 1. And the remaining 2 elements are not sure. So if they are both 1s, so we return the count of operations. Otherwise, we cannot make all elements to be 1. So we need to return -1. So this is the problem. This is the main idea content in the sliding window with fixed window size, but varying moving forward step. So this can be also regarded as a full walkthrough for example 1. So now let's look at coding. As for the coding, you just need to translate what we said into code format. Let's initialize a result variable. So this integer, or this is the count of the needed operations. The final state is what we want to return. And then we can use a while loop, right? So I is starting from 0. Then because each time we consider a window size of k, so we want this not win while I is less than length of nums minus k plus 1 actually, right? So here, because it's 3, so -2. Then if nums I is 1, right, it's corresponding to this scenario, right? So we move forward I increment by 1. So in this case, we don't need to do flip operation, so we don't increment the count. That's all the result. All the other cases, we need to return the count of operations by 1. And then we check how many steps we need to move forward, or what's the size of moving forward step. So first, we do the conversion, right? I plus 1 is equals 1 minus I plus 1. So this the I minus 1 minus will do the flip between 0 and 1. If you are 0, so 1 minus 0 is 1, you do the flip. If you are 1, so 1 minus 1 is 0, you do the flip, right? Similar thing for nums I plus 2 equals 1 minus nums I plus 2. So notice that due to this while condition, so the I plus 1 and I plus 2 are always inbound. So this is always valid, right? Then we check if nums I plus 1 is 0. Then we need to take care of this guy, right? So I increments just by 1, right? Otherwise, if nums I plus 1 is also 1, then we check if nums I plus 2 is 0. So if this guy is 0, so we need to take care of this one. We increment I here. Otherwise, so we have this, in other words, we have such a scenario. 0, 1, 1, right? So we not 1, 0, 0. So we are going to move step 3. So I increment by 3, right? So once we finish this while loop, we are going to check the last 2 elements, right? If because our window size is 3, so we can make sure the n minus 2 elements are all 1s. Then if nums are -1, right, equals 1, and nums -2 is also 1. So in this case, we are sure all the elements are 1s now. So we just need to return the count of the number of operations. Otherwise, we return -1. So this is a solution to this problem. So let's first do a test, then do some comments. Yeah, it passes one example. Now let's directly check the generic case. Yeah, it passes all the generic cases. So here I found that the interesting point for this problem is that we are using sliding window, but here the window size is always 3. However, the moving forward step can be 1, 2, 3. In other words, it's not a fixed size. So I guess with that said, that's about it for the current problem. If you are interested, you can check this problem. So this problem basically change this 3 to be a general element key, right? This marked hard, but if you follow the idea, you can do it in a relatively easier fashion. With that said, I guess that's it. Thank you.